In undertaking mine rehabilitation, various activities are performed. This can include decommissioning of the existing mine infrastructure. It can include treating any potential contaminated land, and also creation of a final landform which can then be vegetated into its natural state. Before any mining is initiated, an environmental investigation will take place, and this will allow for the development of a closure plan and a remediation strategy. Seedlings can be taken from the native environment, which can then be stored so that as progressive rehabilitation takes place, that vegetation can be gradually reintroduced to the landform that is produced. This ensures that the native species that were originally on the mine site before activities were undertaken can be reintroduced. Geosynthetics are successfully used in the process of mine rehabilitation. There are benefits that can be achieved that include an economic benefit, whereby geosynthetic materials can replace traditional construction materials such as sand, gravels and clay. There's a technical benefit where the consistent properties of geosynthetics can fulfill critical functions that can't be achieved with a natural material consistently. The geosynthetic materials have an environmental benefit. Materials such as GCLs and geomembranes perform a barrier function that protect the surrounding environment, and geosynthetic materials can be used to stabilise the landform to create a safe and secure landform for future use. Legacy mines are where historic mining has taken place and there's no security in place to remediate those. There are over 80,000 legacy mines across Australia that need some form of remediation. Restoration of these legacy mines can enable sustainable use. One example includes mine pits that can be used for hydropower energy generation. In cases where there are old disused mine waste or tailings, the technology now exists, for example using geotubes to now mine that waste material and recover valuable minerals from that waste material. R&D greatly reduces the risk for using geosynthetics in mining. So by understanding how mine chemistries react with different polymers, we can demonstrate longevity. We can test this in the R&D research laboratory, the GRID, by selecting the most appropriate polymers for the mine waste in question. An example is high pH and low pH mine waste may require a certain polymer, such as polypropylene, where polyester may not be as acceptable. Modelling and calculations can be undertaken on geosynthetics to ensure the most appropriate reduction factors are used, and this can then demonstrate how geosynthetics will function in the long term. Geofabrics have a range of geosynthetic solutions for mine rehabilitation. This includes barrier materials such as GCLs, HDPE and bituminous geomembranes for containment of contaminated liquids. It includes erosion control products that can be used in the construction of final landforms. We also have Geotube products that are used to dewater large volumes of slurry and mine tailings waste. Geosynthetics are used to stabilise and reinforce the mine site to ensure safe and stable land for future use.